This is a problem where a 4-digit number is divided by a single-digit number, resulting in a 3-digit quotient and a remainder. With so many little blocks, my head is spinning. Inside, there's only one number, which is 4, and that's the remainder. This is our first breakthrough. Why? Because the remainder must always be smaller than the divisor. So this single-digit number must be greater than 4. That means it's one of the numbers from 5 to 9. So do I have to try each number one by one? That's why what comes next is even more important. We need to find the golden triangle. A 2-digit number minus a 1-digit number equals a 1-digit number, which forms a golden triangle. Again, a 2-digit number minus a 1-digit number equals a 1-digit number, another golden triangle. You might ask, teacher, what is a golden triangle? I don't understand. Think about it the other way around. A 1-digit number plus a 1-digit number equals a 2-digit number. The largest 1-digit number is 9, and 9 plus 9 is only 18. What does that mean? When you add a 1-digit number to another 1-digit number, the 2-digit result will always be in the teens. Similarly, when you add a 1-digit number to another 1-digit number and get a 2-digit number, it will always be in the teens. Now let's look at the last 4 and add this number. It's also a 2-digit number. What does this tell us? Here, the tens digit is also 1. This is what we call the breakthrough point. And if we look closely at this 1, it's not only the tens digit of the 2-digit number, but also the final difference after the subtraction above. So let's think about this. If you add 1 to a 1-digit number to make a number in the teens, you have no other choice. It can only be 1 plus 9 to get 10, because as long as the number is less than 9, adding it to 1 won't reach a 2-digit number. Now let's think about a number between 5 and 9. If you multiply it by a 1-digit number and the result is 9, there's no other possibility. It can only be 9 times 1. And pay attention to this. This spot is between 5 and 9, so here it's 9 and here it's 1. In the same way, let's look at 9 times this number. If you want a 1-digit result, it can only be 9 times 1 to get 9. Conversely, if you think about 1 plus 9 to get 10, the units digit here is still 0. Where does this 0 come from? It drops down from above, so this spot is 0. Next, let's look here. Again, the only 1-digit number that 9 can multiply to get is 9 times 1, which gives 9. Then, working backwards, 4 plus 9, where does the 300 come from? It drops down from above. This problem is solved in 2 steps. First, look at the remainder. Second, find the golden triangle. If you understood, make sure to follow.